That's where those lines came in. Does that make sense? Any questions with that right now? Let's go to number 2 on that sheet. So, with the top one of number 2, already in slope-intercept form, we're going to go to plus 3 on the y-axis. We're going to go down 5 over 1. And remember, we're doing solid line here because it's greater than or equal to. And if we were just doing one inequality, we would shade one side or the other by testing 0, 0. But let's figure out which side we would shade of this, but draw the arrows instead of actually shading it. If I pick my test point, again, that's that point, 0, 0. Plug in 0 for y and 0 for x. Negative 5 times 0 is 0. 0 plus 3 is 3. Right, that's false. So I don't want to shade this side of that. I want to shade this side. So again, I'm going to put a couple arrows instead of shading it because I don't know where I need to stop shading right now. So let's move to the red line. There's no x here. There's like a 0x, a 0 slope. When it has a 0 slope, it's a horizontal line through this y-coordinate. Y-coordinate at negative 2. It's going to be horizontal, flat line. Is it going to be a dotted one or a solid one? Dotted because it's just greater than. So then I figure out which side of this to shade. Remember, this is y greater than negative 2. I want all the y-coordinates greater than negative 2. That's going to be like negative 1, 0, 1, 2. All the ones on that side. So now I shade the region that's covered by both of them. Okay. I have to be on top of the red line, and I have to be towards the right of this blue line in the region I shade, because I only want to shade what's in common to both of them. So that's going to be right there. Right? It's on top of that red line to the right of that blue line. That's what our arrows are good for, rather than having to erase double shadings.
Right.
Okay. So looking at this, don't do any of the math, but if I said, is the point 5, 1 a solution to both of these inequalities? You would say what?
Yes.
Don't plug it in. 5, 1, it's going to be over here, right? It's in the shaded area. It's a solution. Is the point 0, 0 a solution to both these inequalities? No, because it's not shaded. What about the point 2, negative 3? Is this a solution to both of them? It's a solution to the blue one, right? Because it's on the right, but it's not a solution to both of them. Only the shaded area is a solution to both. That's what the shaded area is good for. Every point in that region is an answer to both of these inequalities.
So if they're not, you just they don't.
If there's no double shaded area, we'll go over that in just a second. Good question. Number 3. Okay? So, yep, you can try it, but what do you have to change about the top one before you graph it?
Y by itself.
Y alone, get it in slope-intercept form, move that x over by subtracting it. So this means it's going to be 2 on the y-axis. What's my slope in this one? Negative 1, so that means down 1 to the right one. And it's going to be a dotted line because it's just greater than. And then I figure out which side of this would I shade. Which side has all the solutions. So I can pick my test point, 0, 0. If I plug in y is 0 and x is 0, that says 0 is greater than 2, which is false. I don't want to shade that. I would want to shade this side. I'm going to do a different color there. I would want to shade this side. And I'll just put 2 or 3 arrows to say, make sure I'm on that side of the red line. So, now this one down here, I have to get y by itself before I can graph. But there's like a -1 in front of this y. So what I could do is I could subtract 2x from both sides. Then I'd be left with -y greater than 1 minus 2x, right? Then you would have to divide both sides by -1. But when you divide by a negative, what happens to the symbol? It flips, right? So there's a lot of ways that make a mistake there. One way I could make this positive is just by moving it to the other side by adding it and then moving the 1 over. So whatever way you do it is fine, okay? But that's probably the easiest or less likely to make a mistake. And then we'll move that +1 over by subtracting it. And that is what we'll graph. If you did it the other way, that's fine. Just make sure when you divide it by a -1, you flip the sign. So we'll go to -1 on the y-axis. We'll go up 2 to the right 1. And then we will put a dotted line because it's just greater than. And finally, we have to figure out which side to graph. So we'll plug in our test point. And our test point is true. So I want to shade over 0, 0 on that one. Oh, no, thank you. It's not true because that's 0. Thank you. That's because 2 times 0 is 0. I wrote. Our test point is false because I get -1 greater than 0. So I don't want to shade 0, 0. I want to shade on this side, which means the common area is right there. You only shade the common region, the region that's shaded by both. Last one here. 1 or 2 minutes to try this one on your own. I'll come around and check if you get stuck. And then I will go over. Neither of these are in slope-intercept form. So we have to get y by itself. We need to move that 3x to the other side. Since it's positive 3x, we will just subtract it. And the top one should look like y greater than or equal to -3 minus 3x. So this is what we're graphing. Means we'll go to -3 on the y-axis. And we can either go down 3 to the right one, or we can go up 3 and back to the left one. Either way. And we need a solid line through that because it's greater than or equal to. We figure out which side of this line we want to shade by testing 0, 0. If we plug in 0 greater than or equal to -3 minus 3 times 0, well, that's minus 0. So I get 0 greater than or equal to -3, which is true. Right? So I would shade towards 0, 0. So I'm going to put a couple arrows to remind me to be on that side of that line. Yes, question?
Since they're both -3, wouldn't you go down 3?
Right. I started, so you could go down 3 to the right one, or it's the same thing as going up 3 and back 1. Right. Yeah. And this one, to get y by itself, remember you save the thing closest to the variable last. You undo multiplication last. So we're going to move that x over first by subtracting it. Okay. Then undo the multiplication by 2 by dividing. But remember, whenever we divide one thing, we have to divide everything on both sides. So y less than or equal to 2. This is probably the part that caught some of us off guard here. This is like a -1x, right? So I'm going to go ahead and write the -1 over 2x now to remind me that it's a -1/2 slope. Because I can't divide these, so I'm just going to leave it as division by 2. Yes, question? On this one? Uh-huh. So you're going to start positive, and then what was your question? Right, so you want to go down 1 and over 2 first. and it'll be solid through that. Let's test our test point here. That says 0 less than or equal to 2, which is true. I want to be on this side of that line, so the shaded region, or the common area, is right there. So just by looking at this, would 1, 0 be a solution to both of these inequalities? 1, 0 would be here. It would be in the shaded area. Now, let me ask this. Would 0, 2 be a solution to both of these inequalities?
No.
0, 2.
Yes.
0, 2 would be, even though it's on that line, it's on a solid line. And anytime it's on a solid line, that means it's included. It's true. If it's on a dotted line, it's not. Okay. Same with, like, if you said 0, negative 3, that would be a solution to both of these inequalities because it's on a solid line. Okay. It's included in both. Other questions on this? All right. That's the end of chapter 6 with an introduction to systems of inequalities.